Today we are going to talk about how to graph linear functions. We have done this before, so we will review creating a table of ordered pairs and graphing those to create our lines. But we're also going to learn about x and y intercepts, how to find them, what they represent, and how to use them to graph a line, because sometimes it is easier to graph a line using intercepts than it is to create a table of values. Let's just review linear equation. I have that down here. Remember, linear represents line, so it's an equation whose graph is a line. It's a function because each member of the domain is paired with exactly one member in the range. So we've talked about functions before, we're just bringing it in. The solution of an equation with two variables is two numbers. So let's just take a look at an example. What am I talking about here? Well, I'm talking about x and y. Let's say I give you the equation y equals negative 2x minus 3. So here are my two variables, x and y. In order to find solutions that make this equation true, we can substitute numbers in for x and solve for y. So again, we want to find ordered pairs that make this equation true. That's the whole purpose. And then we can graph those. How many points do you need to graph a line? Can you do it with just 1 point? You actually need 2. 2 is the bare minimum. So if we had a table of just 2 values for x and 2 values for y, we'd have 2 ordered pairs. We could graph our line. Usually you're asked to come up with 4 solutions or so, and that's just to make sure that your calculations are correct. Because as you start graphing, if you notice that they seem to line up and then you have one oddball point out here, you know, I don't want you saying, oh, it's not really a line. It should be a line. I would say check your calculations for this point, okay, because most likely everything you should be graphing should line up. So that's just an aside. So let's go ahead and make our table of values, x and y. Remember, you can choose whatever you'd like to put in for x and then solve for y. So what numbers would you like to choose? Well, usually I like to stick around the origin. Sorry, I'm trying to get a straight line there. Maybe a couple of negative numbers, maybe 0. That's always really great to work with. Maybe 1, 2, 3. So it all depends. You could put in all positive numbers. You could put in all negative numbers. I wouldn't be substituting numbers in like 100 unless you plan on graphing or creating a coordinate plane that extends that far. So let's just do this. Say negative 1, 0, 1, 2, something like that. Okay, so how do we figure out what y equals when x equals negative 1? We will substitute x equals negative 1 into the equation. So y equals negative 2 times negative 1 minus 3. This is a minus sign. If you'd like to rewrite it as plus negative so that you're able to calculate easier, please do so. You don't want to make mistakes because of negatives. We've been working a lot with them, so just pay attention to those minus signs. Here we get negative 2 times negative 1, that is a positive 2, plus negative 3, and that will give us negative 1. So one ordered pair that makes this equation true is negative 1 equals negative 1. And I can prove it over here by putting a negative 1 in for y, a negative 1 in for x, and seeing if I get a true statement. That's the whole idea. So negative 2 times negative 1 is 2. 2 minus 3 is negative 1. So this does, in fact, check. Let's go ahead and substitute 0 in. Be careful with 0 because of the minus 3. You just need to be careful. So I recommend that you actually write it out, so that you don't miss the fact that you have 0 minus 3 or 0 plus negative 3. That would give you y equals negative 3, not positive 3. And so my next ordered pair would be 0, negative 3. We can do this again for 1. I'm just going to talk through it. When I put a 1 in for x, negative 2 times 1 is negative 2. Negative 2 plus negative 3 gives me negative 5. When I plug in a 2 for x, negative 2 times 2 is negative 4. Negative 4 plus negative 3 is negative 7. So here are a couple of other ordered pairs. When you check your answers in the back of the book, when you're doing the book work, don't be surprised if the ordered pairs you have created are not listed, because there are an unlimited number of correct answers here, values for x and y that make this equation true. And we could keep going, but I'm not going to. That would take too much time. Okay, so what do you do next? Well, you graph the line. You can just watch. You do not have to copy this down in your notes, or you can just do a quick sketch in your notes. That would be fine as well. Okay, so x and y. Make sure everything's labeled correctly. You know where the x-axis is, know where the y-axis is. When you are graphing your points, you know, here I might just want to count by ones. 1, 2, 3, 4, 5. I'm only going to label every fifth dash, 3, 4, 5, so that I'm not overcrowding my axes with numbers. 4, 5. 1, 2, 3, 4, 5. Okay, so you can do the same thing. Let me see, what point did I have first? Negative 1, negative 1, 0, negative 3, 1, negative 5, 2, negative 7. And as you can see, everything lines up really, really well. Let me get my little arrow here. And you do want to extend your arrow. Make sure it has, or your line, make sure it has arrows on either end. Okay, and this line represents all solutions to the equation y equals negative 2x minus 3. That's why we connect all of the points, because I'm showing that this is a solution, this is a solution, this is a solution. It might be harder to figure those out because they involve either fractions or decimals, but they still work. And when you get all of your points together, they create this line. Okay, so again, it's fine if you just created a quick sketch of that. So let's talk about intercepts. What are intercepts? Okay. X-intercept and y-intercept. Basically, these are the points where the line that you're graphing crosses the x and the y axes. So the x-intercept is where the line crosses the x-axis. And the y-intercept is where your line crosses the y-axis. If you knew both of those points, like I have here in black, could you graph this line? Absolutely. And sometimes, depending on the equation given, it might be really easy to figure the intercepts out. If you know what the intercepts are, you don't have to make a table of other values. You can just graph both of those, connect them, and voila, you have your line. So what does this type of point look like? Well, the x-intercept has some number, comma, 0, because on the x-axis, all of the points are some number, comma, 0, like 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, so on and so forth. On the y-axis, every x value is 0, and then there's some number for y. So 0, negative 1, 0, negative 2, 0, negative 3, 0, negative 4, as we go down the y-axis. We can use this information to find intercepts given an equation. So, what might that look like? Let's say we have an equation that looks like this. 2x plus 3y equals 6. Now, could we go ahead, put values in for x, and solve for y, make a table? Of course, you can always do that. But it's not as easy in this case because we don't have y alone like we did in the last example. So let's see how intercepts can help us come up with a few points here. To find the x-intercept, so I'll just say first, let's find the x-intercept. We are not sure what x is, but we do know that y has to equal 0. So we're going to substitute 0 in for y, and this is different because usually we're just substituting numbers in for x, but you can also substitute in for y, and solve for x. Okay, so we'll put a 0 in for y, and we will solve for x. We'll get some number for x. So let's go ahead and do that and see what we get. So 2x, I don't know what that number is yet, plus 3 times 0 equals 6. Zeros are great because they usually allow something to drop out. 3 times 0 drops out. In this case, you get 2x equals 6. We divide by 2, you get x equals 3. Now, we're not done because remember we need to have an ordered pair for the x-intercept. So basically we are saying that when y equals 0, x equals 3 because we substituted 0 in for y and we found that x was equal to 3. How do you put that in an ordered pair? Well, you'd reorder it as 3, 0. So 3, 0 is a point that makes this equation true. And again, you can check it. I'll check it over here. So 2 times 3 plus 3 times 0 should equal 6. Well, is that true? 2 times 3 is 6, plus 3 times 0 is 0, 6 equals 6. That is true. So this point makes the equation true. And it also happens to be the x-intercept. Let's go ahead and find the y-intercept. I'm just going to write down my equation again since I need to scroll down. Okay, so let's find the y-intercept. And it doesn't matter which intercept you find first. So to find the y-intercept, remember it is 0, some number. Our x value has to equal 0. So I'm going to substitute 0 in for x, and I'm going to solve for y. So let's write that down. We're going to substitute, this time, 0 in for x, and solve for y. Now again, you might be asking, how come I'm not just substituting any other number? We need to use the zeros in order to find the intercepts, where these lines actually cross the axes. You can put in other numbers. Those points just won't represent an intercept. So let's go ahead and see what happens. So 2 times 0 plus 3y equals 6. That drops out. We get 3y equals 6. Divide by 3. You get y equals 2. Now again, we have to write it as an ordered pair. So what does this mean? When x equals 0, y equals 2, that gives me the ordered pair 0, 2. And we can check this one just as we checked the other, just so I can prove to you that it does work. 2 times 0 plus 3 times 2, that does in fact equal 6. So now we have 2 points. We have 3, 0 and 0, 2. And if I wanted to put them into a table, I could. So I have 3, 0, and I have 0, 2. Those happen to be my my intercepts. Okay. It makes graphing really nice. Let's see, 1, 2, 3, 4, 5. And again, in your notes, if you just have a general sketch, that is fine. It does not have to be accurate. Just please make sure that you label your points 3, 0 and 0, 2 so that you understand what it is you were trying to graph. So here, 3, 0, 1, 2, 3, 0 is right here. 0, 2 is here. I have 2 points. I can connect them. Okay, that was freehand. That one was not so nice. But you can use rulers. But again, for notes, freehand is okay. And there's our line. I can find other values for x and y if I wanted to. I could substitute in for x, I don't know, the number 1. Let's see what happens then. So 2 times 1 plus 3y equals 6. That would give me 2 plus 3y equals 6. I have to do a little bit more here to balance, but it's fine. I do get 1 1/3, so that's a little bit tough to graph, but that is true. Again, my line is not accurate. We will practice more of this tomorrow in class. Please bring your notes with you, and I will see you then. Thanks.